get started with today's lesson. Thank you. What we're talking about today is corresponding angles and sides. Corresponding angles between two congruent triangles are going to be congruent. So here, they gave us the two triangles. A is congruent to D. In the figure, angle A has a mark inside of it where the angle's at, and so does D. So those marks signify that those two angles are congruent. If we look at B and E, both B and E have 3 marks, so those two angles are congruent. C and F have 2, so those two angles are going to be congruent. They're going to be the same. They correspond to each other. They're in the same spot. They're congruent. If we look at the corresponding sides, AB has how many marks? 2. From A to B, so AB has 2. So if I look at the other triangle, I'm looking for a side that has 2 marks, which is DE, and they are congruent. They are corresponding. If I look at BC or CB, it has 1. EF has 1, so they are corresponding. They're going to be congruent. And lastly, AC has 3. FD has 3, so they are congruent. Those are the corresponding sides. Now, the last thing we're going to do is actually name the two congruent triangles. Yes, sir. Line segment. These here? So it's saying that these two lines that have 3 marks are congruent to each other. The marks are to show congruency. And any line that has the same number of marks or any angle that has the same number of marks inside of them are going to be congruent to each other. Any other questions before we make the congruency statement? Now, the way we name a triangle is we start off by doing our triangle symbol, and then we essentially trace around the shape. So we can start off with this triangle here first. Give me a vertice of this triangle. Vertice, one of the side angles. So we're starting off at B. Now we can go to A or C. Which one do we want to go to next? A? And the last one would be? So we went from B to A to C. The way that we name the first triangle does not matter. We just need to name it in one of the different ways, because as we said, we went BAC. We could have gone BCA. We could have done ABC, ACB, CBA, or CAB, because I could have picked any one of those 3 to start with and traced around the shape. What's important is the second one. It has to follow the same path. So what angle did we start with? What angle corresponds to B? So I have to start off with E, because we started in the same spot. Now, where did we go next? We went to what angle corresponds to A? And the last one is? And that's it. Because the congruency statement is going to follow the same path and match up. They do, because BA is the first 2, yes? What did side length match up to BA? ED or DE? Oh, sorry. No, you're good. Because, no, that is what I was actually going to point out next, is because BA or AB does match up with ED or DE. Line segment AC matched up with DF. The parts in the statement actually do line up. They match up the way the statement's said. That's why it's phrased this way, because we're lining up what is congruent. The different parts that are congruent are told to us in this statement. Questions on this here? Let's look at our first example. Here we're given these two triangles. So we want to name all the corresponding parts that are congruent. So we can start off with the angles. So we can say J, and we'll do S here in a minute, because J has how many marks inside the angle? So the one and the other one that has 2 is? S has how many on the inside? 3, yeah, it has a lot. The other one that has the same number is? And the last angle is? L is congruent to R. Those are our congruent angles, our corresponding angles. Now we need the sides. So JK has how many marks? 1, yes? So which one has 1 in the other figure? So we're looking at the segments themselves. Because R does have 1. Now we're looking at the line segments. So J to K has 1. S to T would have 1 as well. Yeah, we switched over to segments. Now what would be another line segment that we could use? RS is congruent to KL, because both of those have how many? 2. So they would be congruent. They would be corresponding. And the last one, JL and RT would be the last ones we have not used yet. But they also have, JL has 3 marks on the line. RT has 3 marks on the line. So those two are corresponding. And they're congruent. The last part is our corresponding statement, our congruency statement of the two triangles. Well, let's get a starting point for the first triangle. What's one of the vertices? JKL, let's use that, JKL is our first one. Since we started at point J, the congruent angle on the other side is T, S, R. And I will tell you, there will be a problem like this on the test. Which one? Which part? The angles? Where did we start out with? So we named one of the triangles, yes? What angle corresponds to J? So we have to start at T. The corresponding angle to K is? So since we went J to K, we have to go T to S, and then we finish it up. On the test, this one here would be worth 1, 2, 3, 4, 5, 6, 7, 8 points. Because each one of those angle congruency statements is a point, each one of the segments is a point, and getting the congruency statement's a point, and you get 1 point for doing it. Let's look at one more, and then we'll move on. So when we look at this here, we need our corresponding angles that are congruent. So we can say angle what? And they would be corresponding because they both have 1 mark. The next angle. Well, because we need to name them all. So Y has, yep, M. Your guys. And then X is congruent to N. Because again, we're matching up the marks inside the angles. Okay. We good with the angles? Let's look at the line segments. So what would be one line segment in one of them? MN would be congruent to, if it has one mark, XY. Because we could use MN or MN or NM. We could do it either way, XY or YX. Either order, but we still need the line above it. Another line segment, NP would be congruent to ZX. Because NP and XZ, because both lines have two marks on it, two hash marks on it. And XY and PM, because both of those lines have 3. PM? ZY, yes. It should be ZY, not XY. Thank you. Yep. I think that's where you were. Yeah, I bet you got it right. I got it written wrong. Yes? And the last thing we need is the congruency statement. Any of those would work. Because I couldn't make heads or tails of any of them. I'll go MNP is congruent to MNP. So M starts out with how many marks? X, Z. Now, any of the ones that y'all chose, because if y'all picked one individually that was different than this, as long as they match in the same order, that is the correct answer. Okay? And even on the test, or if we have a quiz over this, I'm not just taking this one here. Any of them that are in the correct order, I will take. So when I grade it, especially when we get to the test, and I look at this one here, I'll be looking at what you wrote and seeing, do they follow the same path? Because if they do, that's the right answer. If they follow a different path, so if MNP, you said ZXY, okay, then that's not it. As long as it follows the same path, that's all we're looking for. The next one? Let's look at the next one. Now this here, because we said the corresponding parts are congruent, yes? Now they told us in the diagram, DEFG is congruent to SPQR. So that's telling me that angle D would be congruent to angle what? Because S came first, yes? Angle E came next. So it's going to be congruent to angle. We can do any number, but I just start with 1. Because the one that they match up to should have the same number. So F, I gave it 3. It's going to be congruent to. And lastly, R and G. So this here is just so that we can see which angles are matching up. Now we can also say, well, DE between angles 1 and 2 that are matching would be the same as S and P, because those are between those two angles, yes? E and F and P and. So we can follow the same thing. So DAFG. So DE would match up to. Or we can also look at the angles, because these are going to match up. So 1 and 2. So we have 1 angle marker, 2 angle markers. Here, 1 and 2. So the line segment between them will be the same as well. As the line segment from S to P will match up to D to E. Huh? Because they didn't need to add them, since they told us that the two figures were congruent. So their parts are going to be congruent as well. Yes, sir. Because we haven't put them up yet. Yep. Because again, these are going to follow the same path. Like we were set up with the previous two, the line segments will follow in the same order. Now DE and first two, SP are going to be congruent. EF and PQ, FG and QR, and then the last set have to be congruent as well. No. So what we're doing this here is because we want to find the value of X and Y. Now, we do have two equations here. One of them is 2x minus 4, and it is a side length. What side length does this match up with in the other figure? 12 feet, yes? We know those two line segments are congruent because they're corresponding, yes? So we'll solve it here in a second. But 2x minus 4 and 12 have the same length. So we can set them equal to each other. Now the other place where we do have an equation is 6y plus x. And it's this angle Q. What corresponds to angle Q? Because it has 3, the other one has 3. So it's 68. So the reason I drew those in is so I could visually see what matches together. So I filled this information in so I can easily look at it to see where it is instead of having to go back up into the congruency statement to see where the parts line up. Now, this one in green has how many variables? 2. Because here we have 6y and x. In Algebra 1, did you ever solve for 2 variables at the same time? No, we can only solve for 1 variable at a time, yes? The other equation, we have 2x minus 4 is equal to 12, yes? Can we solve that for the value of x? Yes. Any questions on how we got x equals 8? So we do know the value of x for this here, yes? Yes. So in this equation over here, the value of x is 8. So what we can say is that we have 6y plus 8 is equal to, so here, even though we were given an equation in 2 variables, so let's work it out one step at a time. We can subtract 8 from, so here the 8 and 8 cancel, tell us that 6y is equal to. And that's it. And that's all that it's asking us for. Questions on this here? Let's look at this here, guys. So here, we want to find the value of x and y. Now, they told us that DEFG is congruent to QMNP. Now, we can put all the information that we did on the last one to start with to show the congruent parts, or we can do just the angles or just the sides. Because once we get that set up, we can see how it matches. Now, so if we did the angles, Well, I can say D is congruent to. Yeah, I mean, that works as long as you have a way to signify to yourself which angles are matching up. E would match up with F, N, and then and G. So now that we can see how they match up, how they go together, yes? Now we do have two equations again. We have x minus 2 and 3x plus 2y. Plus 2y. Now the 3x plus 2y is an angle, and it's the measure for angle P, yes? What angle matches up with angle P? Which is? So 3x plus 2y is? 84. Now x minus 2 is the length of MQ. What side length matches up with MQ? It is because Q and M, so from 1 to 2, our angle with one marker to 2. D to E, one marker to 2. So we would solve for x first, and we can do that by?
Add 2 on both sides.
Adding 2 to both sides, which tells us x is equal to? Yes. So now that we have the value of x is 10, we can plug it into the other equation and say 3 times 10 plus 2y is equal to 84. So let's do it one step at a time.
30 plus 2y
All right. So 3 times 10 is?
30.
Equals 84.
Take away 30.
Because 30 minus 30 would be 0. So 2y is equal to 54. So we would divide 2y and 54 by 2 to get y by itself. Questions on this here? And that's all we have to do for these here, because it's really just matching up what parts are congruent and then solving for the x and y. Any questions on this here? Let's go on and look at the next piece. We'll go on and skip this one here. That's not mainly important. So what we're looking at this here is the reflexive, symmetric, and transitive properties. We can say this with congruent triangles. So the reflexive property of triangle congruency for any triangle ABC, triangle ABC is congruent to itself. Because our reflexive property, as we said before, A is equal to A. Symmetric, if triangle ABC is congruent to DEF, then triangle DEF is congruent to triangle ABC. We can flip the order of the congruency statement. Our transitive property of congruency is if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to JKL, then triangle ABC is congruent to JKL. We're gonna have this won't because we'll mainly, if we were using this, we would use it on proofs, but we're not using proofs for this here. The main last theorem that we're looking at is this here, the third angle theorem. If two triangles in one triangle are congruent to two angles in another, then their third angles are congruent also. So this here, so we could just say A is 50 and B is, no, I'm just putting two measures down, guys. So if we said that A was 50 degrees and B was 60, then I thought I was, yeah, it's the other way. Then these are going to be the same. Well, any three angles in a triangle always add up to be what?
180.
So if these A and B match up to D and E, well, C has to be the same measure as, it would be 70. So those have to be the same. Because if two angles in one triangle match up to two angles in the other, the third angles have to be congruent also. Now, what is very nice with this here is this is really leading us to helping us in showing that two triangles are congruent. Because before this, to be able to say, guys, that two triangles are congruent, we needed to know that all three sides, guys, that all three sets of sides are congruent and all three sets of angles. We needed everything in the triangle to be able to say that they're congruent. These last two here, these last few problems here, we're going to show that the two triangles.
Tell Lauren, please come to the office. Chloe, tell Lauren.
Well, why don't you just look at that square shape? Probably just walked out. If she did. Bro, dude, Miss Shack was in here. You guys knew all this.
Yes.
Yeah.
Huh? Guys, we can talk about that later. So I went on and traced the triangles and drew them down. Because a lot of the times, if the triangles, guys, are drawn over the top of each other, it's a little bit hard to see. So I went on and essentially retraced them down here. This triangle over here, we can say is BDC. And this other one would be ADC. Now we know that angle D down here is 1. Now they told us that the measure of ADC is 30 degrees. DAC is 45. So C over here would be 30, and B up here would be 45. Now what we want to find is the measure of angle BDC. BDC. Guys, Logan, focus up here, guys. Now we want to find the measure of BDC. Now because of our angles, we know that this angle here and this angle here are going to be the same. Now these three angles here add together to be 180. So x plus 30 plus 45 is going to equal 180. Now we can add 30 and 45 together, which gives us subtract 75 from both sides, which tells us x is equal to 105. So the measure of our angle is 105. Any questions on this here? We have two left, guys, this one and the next one. So here we want to find the measure of angle P. Now Q and C are both 90 degrees because they are both right angles. A and R both have one angle marker, so they're going to be congruent. Since A is 52 degrees, R has to be 52. Now we can solve for the value of X because these three angles add together to be 180. So we can say X plus 52 plus 90 is, well, 52 plus 90 is,
Angle P is 38.
52 and 90 is 148.
148.
And if we subtract 148 from 180, subtract it from both sides, almost.
Are you sure it's 148?
132, sorry.
I want 42.
Yep, because this here should be 142.
I got
Yes.
A equals 38.
Yep. I don't know. I was already doing the subtraction. That's where I got the 8 from. Any questions on this here? In this here, let's do this last one and then we will be done with notes for today. Angle D and angle S are congruent because we were given the angle marker, yes? D in C and R in S are congruent to each other.
Yeah,
How would they be congruent?
because S is.
Yes,
Oh.
but they also are what? Vertical angles. Vertical angles are congruent. So we can say that these two angles are congruent to each other. Now, do we have two angles in both triangles that are congruent? So the third angles have to be congruent to each other, which means angle C is congruent to angle. So C is 75 degrees. Or here they're asking for the measure of DCN. DCN would be questions on this here. And we are done for